Hi everyone, I'm Wan from University of Virginia, and today I'm going to talk about the neutrality of Lagrangian loss invariant under positive contact surgery. So given an oriented Lagrangian knot L inside the contact Riemann-Manifold Y-axis, Liska, Oswald, Lifshitz, and Sabo define the Lagrangian invariant, the loss invariant L of L inside the H of K minus of the minus Y and L. And the neutrality theorem is stated as follows. So given two disjoint Lagrangian L and S inside the contact Riemann-Manifold Y-axis, the contact plus N surgery on S induces a map F from the H of K minus of minus YL to the H of K minus of minus YS and then to LS. Moreover, if Y is a rational homogeneous spheres, it maps the loss invariant of L to the loss invariant of LS. Okay, so next I'm going to talk about the construction of the loss invariant. So in other words, given a Lagrangian knot L in Y-axis, I want to construct a double-pointed figure diagram describe minus YL and an element in the T beta and T intersect T alpha. So we start with an open book P fees correspond to Y-axis, such as L is on the page. Moreover, we choose a basis AI for P, such as L intersects A1 at one point, and L intersects AI is empty for I not equal to 1. Next, we set our surface sigma equal to P1 union minus P minus 1, and alpha equal to AI intersects the AI bar, where AI bar is the identity map in the P minus 1 side. And we set beta equal to BI union phi BI bar, where BI are just the transverse push-offs of AI, such as BI intersect AI transversely at one point. Last, we put our Z and W, such as Z is in the outside regions and W is between A1 and B1s, and we choose the correct W such that it describes the oriented L. Next, we can see that this sigma beta alpha WZ is exactly described minus YL, so we can associate this CFK minus. And moreover, we let X equal to X1 to Xn, which equal where Xi equal to AI intersects BIs, and it's inside the T betas intersect T alpha. Next, so by the theorem of Liska-Oswald, Lifshitz, and Sabo, the X is the cycles in CFK minus of minus YL, and the homology of X equal to the loss invariant of L of L is a Lagrangian invariant for the Lagrangian knot L. So moreover, the loss invariant of L minus, where the L minus is the negative stabilizations of L, is equal to the loss invariant of L. And the loss invariant of the positive stabilization is equal to U times the loss invariant of L. Next, let's see our applications. So we consider these two Lagrangian knot AB, which are mostly all isotopic to the mirror of 9/7, and the theorem is that they are not Lagrangian isotopic. So the trick is as follows. So we do these two Lagrangian, the contact plus two surgeries on the unknots, and the resulting ones are the two stabilizations of this called the E33 knot and two negative stabilizations of E51 knot. And those two knots are both mostly mirror of 7/6 knot. So by the neutrality theorem, it maps the loss invariant of A to the loss invariant of the E33s, and the loss invariant of B to the loss invariant of E51s. And by Oswald and Lifshitz, those two are not the same. So that tells us the loss invariant of A is not the same as loss invariant of B. So they are not Lagrangian isotopic. Thanks.